Good morning. Today we'll look into multiple granularity. In our previous lectures, we have seen lock-based protocols. Whenever transactions are executing concurrently, in order to maintain consistency, we go with the concept of isolation, which is implemented through locks. That is, locks guarantee exclusive use of the data item in a transaction. So, before you want to modify the data, you apply for the lock, complete your task and then release the lock so that another transaction can have access to that particular data. Now, when I talk about lock granularity, it is about the level of usage of the lock. It says locking, the multiple granularity locking manages locks at various levels of the database hierarchy, allowing different transactions to lock the different resources at different granular levels. It is like you either lock the complete database or go to the tables or lock individual pages or go for records or even fields. Let's try to see these levels one by one. When I say the highest level of granularity is you are going to lock the database. That means transaction T1 which wants to access a particular database or one of the table in the database, but I am locking the complete database. When T1 has requested, T1 wants to access table 1, T2 wants to access table 2. In spite of that, when T1 access or request for lock on database, once it is granted, then the transaction T2, even if it wants to access a different table, it has to wait till this particular transaction T1 releases the lock. So, this kind of lock, highest level of granularity. As we go down, it is finer granularities. So, what is happening? You have logged at the database level. Because of that, within the database, there are multiple tables. Even if another transaction wants to access a different table, it is not allowed till the time this lock is realized. So, this kind of things are good for batch processing. That means generally the processes are executed one after the other. Whereas for a multi-user DBMS, it is unsuitable because we want concurrent execution. Many users wants to access. We want things to run parallelly. So, this is not suitable. So, the next level when you say, as we have understood, a DBMS or a database will have multiple tables or maybe so-called files. At table level, if I want to lock the system, that means transaction T1 which wants to access table 1 will apply the lock only for table 1. Now, within that table 1, if it wants to access the record number 5 and another transaction wants to access the same table for record number 7, it is not allowed because you have applied the lock at the table level. So, within the same table, if transaction T2 wants to access, it is not allowed. Whereas, like in the earlier case, if transaction T1 wants to access table A and T2 wants to access table B, they can run simultaneously. So, T1 will apply the lock on table A and T2 will apply the request for the lock on table B. Both of them will be granted and they can run simultaneously. Provided both of them are requesting for the same level, they need to wait. See, T1 has been granted on table A. Then on table A, if T2 requests for a lock, it has to wait till the time T1 unlocks it. This is what is table level or the file level of granularity. Moving ahead, we have a page level granularity or page level lock. What does this mean? You know that when you are storing the data in the memory, you are doing it based on the disk page concept. You have been seeing this in memory management of operating system, that memory is divided into different disk pages and you will refer to that. So, I apply lock to the entire page, and a page may contain multiple rows, several rows from one or more tables. It may so happen that you have two rows of the previous table and remaining 10 rows of the next table, anything like this. So, it is possible that a page may contain multiple rows from one table or from multiple tables. Now, when I apply lock at the page level, look at this. Here transaction T1 wants to access the first row. It is applying lock on page 1. Okay. Now, it is granted that particular lock and it is accessing, it is interacting, it is modifying. At the same time, transaction T2 wants to access row 5. When it wants to access row 5, as you see, row 5 is in page 2, hence it will be given that particular access. That lock is granted and it can lock and it can work. Whereas, it is asking for row 2. Row 2, as you see, is in page 1 and that has been locked by transaction 1 for accessing row 1. So, transaction T2 has to wait in order to access row 2. So, it will not be granted with that particular lock because page 1 is already locked by transaction T1. Now, remember, this is the currently frequently used locking granularity for our DBMS locking methods. So, page level is more comfortable or more worth it when you are talking about locking, because it is not too high, not too low. In case of too low, there will be too much of overhead. In case of too high, concurrency is very, very low. The next level is your record level. What we have seen is row wise or row level or record level. So, if you want to access row 1, you apply lock only on row 1. So, that within that same table, row 5, row 6, row 7, whatever you are talking, it can be individually accessed by other transactions. Looks very good, so that more of concurrency is allowed, but the problem is, though it improves the availability, there is going to be a high overhead because lock exists for each row. Before applying, you have to apply lock for that row, access it, release it, maintain that list of locks. All these things are going to be the overhead. Of course, moving further, in order to increase the concurrency, you can even apply lock on field level also. Same row, if you are modifying field 1, another transaction can modify field 2. It can even apply lock at that level, but it will be too much of hierarchy. Coming to this hierarchical structure, we can imagine it in the form of a tree structure. So, if you see it that way, here this is your database level. This is actually called as area, which is nothing but your table level or file level, and this is going to be your page level, and this is going to be individual record level. So, now when I talk about lock granularity, it introduces additional locks in along with those what you have already learned. It is your shared lock and exclusive lock, lock for reading and read write operation. Here we call it as intention locks. Intention locks are basically just showing their intention to achieve or request for a lock at the lower level. For example, I want to have a read lock or a shared lock applied on this, then I need to apply intention lock of IS at these levels, so that here when I come, I can directly apply for the shared lock. Okay, we will just try to see that here. Types of intention lock. So, multiple granularity locking protocol uses two new kinds of locks called as intention lock. So, intention locks indicate the intention to acquire a finer grained lock in future. Down the line, at finer levels, that means lower levels, it is going to accept or request for a particular lock. It is showing its intention. So there are three kinds, especially intention shared lock. It indicates the intention to acquire a shared lock at the lower level. Remember, intention shared locks conflict only with X locks, because you know read only conflicts with write. That is why they will conflict only with S locks. Coming to intention exclusive locks. This indicates the intention to acquire exclusive locks at the lower level. You know write always conflicts with both read and write. That is why IX conflicts with S and X locks. Now there is another introduction which is shared intention exclusive, which may obtain a shared lock at the current level and may intend to obtain an exclusive lock at the lower level. So this is the kind of locks that we apply. They only tell that in future, that is down the line, I would like to apply that particular lock on top. So that whenever you are comparing or whenever you are allocating or allowing it to apply for the lock, you will see this compatibility matrix, because which locks can coexist. Now for example, if you see IS, we said IS conflicts only with exclusive locks. That is why SIX and X it will not allow, they cannot coexist. But if you have applied IS on a higher level, you can also apply IX, it is allowed. So that is what this matrix talks about. Whereas if you apply IX, then IS and IX only is allowed, no other things are allowed, because you have seen that IX conflicts with both read and write. That is why read and write cannot coexist. This is what is the compatibility matrix says. You can go through them in order to understand how it works. Look at this. The transaction first locks the root node, what we have seen at the database level. What is that? Intention lock, root node, so that it can be locked at any node. So locks are granted as per the compatibility matrix indicated above. So if you have applied for IX and if you are intending to take IS, can it coexist? That is what you need to see here. IX is already there, I want to apply for IS. Yes, it can. But when you come down and say that you want to go with S, it will check, is X still there? If it is there, don't allow. If it is not there, allow it. It's like that. Okay. Then the transaction can look at this only, lock node in S or IS mode. If it already locked all the predecessor nodes in IS or IX, if they are all intentions are shown clearly, then you can lock it in S mode. Whereas X, when you are saying, if it is already locked in SIX or IX mode, you can. If it is in IS and you want to apply the lock X, no, it will not allow you. Coming to this, the transaction must again follow two-phase locking. That means you can acquire a lock provided you have not released any locks. Once you started releasing, you cannot acquire any more locks, you know that. So you can lock a node only if it has not previously unlocked any of the nodes. Because of this, I can ensure conflict serializability. And remember, when we are applying locks, we go from top to down. First you apply at the root level, then come down. When you are releasing, you have to go bottom up. Release the leaf node first, then go up, step up further. So remember, proceed top down when you are locking, unlocking will be bottom up manner. Locking would be top down manner. This has to be remembered. Okay. Now this is the compatibility matrix. So whenever we want to read, you first apply IS, reading intention is shown at the database level, then at the table level, then go for locking the record, okay, or page, and then go for locking the record. Whereas when it comes to, if they are doing it on same table but different records, yes, it is possible, different records. That's why see, first intention lock on both database, table, page, etc. Finally lock on record 1, lock on record 2, lock level when we are talking. So this is possible. Finally, what are the advantages and disadvantages of having locks at different level? it can improve the concurrency. Because I am allowed to have a finer level of lock instead of directly one single lock. I mean, instead of complete database you stop from accessing, you are allowed to stop only that table or only that page or only that record, because of which concurrency is improved. At the same time, you will have reduced lock contention. Assume you have locked the database itself. So many other transaction wants to access the same database, contention for the lock is more. Everybody is waiting in the queue. Whereas flexibility, managing the locks at various levels provides you that flexibility, in turn gives you improved concurrency. But what is the disadvantage? It will be more complex. Naturally, you have to implement and manage so many locks. In single level, when you are saying, the number of locks are going to be less, but in multi-level you have to manage so many locks, and because of which there is an overhead. You have to store them. There should be a lock manager, there should be memory used, and every time you apply for a lock, you need to check that particular table. So, as we discussed, with every better implementation, you will always have a problem associated. You have to always make a trade-off between what is required. So, depending upon the accessibility, or otherwise the request of accessing of that particular table, maybe you can go for the levels. If it is very rarely or concurrent execution is very less, in such situation I go for database level, whereas in a high one I have to see to that database level cannot satisfy the users, multi-users when we have, it cannot satisfy the users. So, I have to go for the trade-off, let it be little finer level, let it be little more of work of managing the logs, but I can ensure more of concurrency. Okay, thank you. Let's try to understand one of the easiest methods or optimistic method in our next lecture. Thank you one and all.